Thank you, Saida and Louis Paul. Good afternoon, ladies and gentlemen. As Louis Paul has said, this conference is about sharing data, understanding what it tells us, and learning how to use it to improve the efficiency, resilience, and cost of our supply chains, essential in a competitive economy. We have three very well-informed speakers on this subject today, with emphasis on the marine sector. I'm very pleased to welcome Dr. Marin Kress, a research physical scientist with the US Army Corps of Engineers. Dr. Marin Kress specializes in navigation system research with the US Army Corps of Engineers, Engineer Research and Development Center, Coastal and Hydraulics Laboratory. Dr. Kress has been involved in waterborne transportation research with special focus on topics related to geospatial data, dredging operations, data accessibility, and decision support tool development since 2013. She's been involved in many interagency partnerships in the US, including the contributing author and subject matter expert for multiple port performance rate statistics reports to Congress through a partnership with the US Department of Trade Bureau of Transportation Statistics. She's acted as the lead for the marine topic on data governance, co-authorized journal articles, and teach classes at the US ACE's AIS analysis package software to access and visualize historical vessel position data. She's also participated in the US Committee on Marine Transportation System, Marine Data Integration Action Team, and she holds an MS in Environmental Science and a PhD in Marine Science and Technology from the University of Massachusetts, and is an alumni of the National Oceans and Atmospheric Administration Sea Grant Norse Fellowship Program. So welcome, Marin.
Visible to everyone?
Yep.
Should be seeing the first slide. Great. Well, thank you, Keith, for that kind introduction, and thank you to McMaster and Transport Canada for inviting me to speak on this. So my topic today is going to be about automatic identification system, which I'll call AIS data, and maritime connectivity. Of course, this presentation and the work behind it could not have been completed without a larger team, which we refer to as the CHL Navigation Data Team. So I'll just give credit to some colleagues there. And without further ado, we'll get into the presentation. So first, what is AIS? I know this audience is an intermodal audience, and some people might not be as familiar with the maritime sector. So AIS is a real-time shipboard broadcast system that sends signals between ships and as well as to shore-based receivers. So it's ship to ship, ship to shore. And it was originally designed as a collision avoidance system. It was not designed necessarily as a data collection system or any sort of historical tracking. It was really designed as a safety technology. And so these vessels are transmitting their AIS message about every 6 seconds. If they're doing some sort of special maneuver, it might be as often as 2 seconds. So it's pretty high temporal resolution data that's available through these terrestrial towers. And I've listed on the left here some of the pieces of data that are included in these AIS broadcasts. So we would kind of describe it as GPS with more, right? It's not just your latitude and longitude, but there's also a timestamp, there's a speed, there's a direction and heading, and then there are some identifying characteristics for the vessel. So the vessel ID, which is a numeric code, there's a name field, the flag, what country flag they're flying under, as well as ship type and dimension. So things like cargo ships, tanker ships, they can self-identify as that. And then the draft is usually the design draft. And some of these lower items on the list are usually entered once and they don't really change much. So they're not really dynamic, but the timestamp, lat long, and the speed are dynamic fields. So they are updated with every transmission. AIS technology is required for most commercial vessels in the US, but it's also being adopted by a lot of recreational vessels by choice. So they want to see and be seen as much as any other commercial vessel. And if you're interested in the technical specifics of what AIS is, the U.S. Coast Guard has an excellent site, and I've listed the website there. And the U.S. Coast Guard is the authoritative body in the United States for enforcing AIS standards. So I mentioned that there are ship-to-ship as well as ship-to-shore transmissions. And so the way that AIS is received on shore is through a series of towers that are placed usually in coastal areas or along waterways. And so this map is from 2018, showing where the receiving towers are located. And the sort of red triangles are their approximate location, and then the green circles around them give an idea of how much coverage area is provided by each tower. So you can see there's excellent coverage along most of the coast in the continental United States, especially along the Great Lakes and the Seaway, and then along parts of Alaska and Hawaii, Guam, etc. So in terms of this presentation, the good news is that there's good coverage in the Great Lakes area. The bad news is that the coverage that I have access to through my system ends around Quebec City. So we don't get that lower Gulf of St. Lawrence in our system, and that's something that we're working on with Louis Paul and his team to see if we can merge some data sources. And for a little bit more background, so once you have this AIS data, these vessel position reports, it's not just tracking where they went. That's not the only application. So just to give a little bit of a broader application here, you can do things like dwell time analysis. And this can get into questions of port efficiency or port operations, perhaps interaction between the maritime and the landside transportation modes. You can look at things like port system resiliency, whether that's to a storm event or a land-based incident or just the weather. This graph on the right side is showing changes in vessel traffic in relation to fog in a gray circle there, or an accident. And you can see that the accident has a bigger spike, and it certainly got more press coverage, but fog can have a significant impact on operations. Other AIS uses, and these are all active research areas that I'm not going to touch on in this presentation, but things like shoreline erosion. I know with the high water levels in the Great Lakes right now that's a concern for some shoreside landowners. Vessel activity before and after dredging, vessel structure interaction. So if you're concerned about breakwaters and if they're performing their function, that's something that's being investigated. And then the last bullet there, which is probably the most important, and I think the focus of this talk, is understanding waterway usage. So if you're not out there with binoculars tracking every vessel, it can be kind of hard to get a sense of how much a waterway is being used. And that is where AIS can make it easy to do that kind of exploration. So some of the products that we use, that we generate, are signal density maps. I think these are a great visualization tool to help people understand. They're not necessarily showing you where more traffic is. They're showing you where more AIS signals are being generated. And so in this case, you can see the top graphic is showing the Great Lakes, and you see a lot of hot spots, which means vessels in this case are probably slowing down as they're going through the Soo Locks, or the part between Michigan and Canada there in the lower part of the figure. And so this is just one example. You've probably seen heat maps for other kinds of transportation, but they can be made for AIS data as well. Another valuable aspect to this data is that you can recreate a vessel track line. So unlike roadways or railways where you know where the vessel or the vehicle is going to move because it can only move along there, of course in the waterway there's a lot more latitude for movement. And so understanding where vessels go and recreating their historical tracks is important. So here on the left, I've done a recreation. These are vessel track lines, and you make those by taking individual position reports and then stringing them together, kind of like beads on a string, to recreate that line. And these vessels in the left figure are sorted by their type. So that is the type that they broadcast in their AIS message. And you can see there's a variety that they can choose from, everything from anti-pollution or a cargo vessel, down to towing and tug and tankers. And all of these are of interest, depending on the question you're asking. And so the same data can be redisplayed. If you look in the figure in the upper right, that's the exact same vessel track information, the same records, but now they're being color coded by speed. So this can reveal, you know, how are vessels interacting with different structures? Are they going too fast through a protected zone for some reason? If there are speed limits in many parts of the waterways, so you can use this to examine those kinds of behaviors. And then what is especially important for my work for the Army Corps of Engineers, because our agency is responsible for a lot of the dredging that happens in the U.S., the lower right figure shows vessels sorted by their self-reported draft. So again, it's not a dynamic draft as they're moving, but it's usually their design draft. And so you can see the deepest drafting vessels in this are following a relatively small course in and out of this particular port. So just to give you some background on what AIS is. For this presentation, I looked at the area around Hamilton, and if you can see, there's a gray box drawn in the left side of the screen there. So that was my request area. And I said, for the whole year of 2019, identify any vessel that passed through that box or that was identified within that box, and then give me their entire position report history for 24 hours. So if they showed up at 2 o'clock on a Tuesday, it went from midnight to midnight of that whole Tuesday. You can make these kind of requests for longer areas, but since this is just an exploratory small project, I picked a 24-hour time range. And what this lets you do, of course, is then see not just, you know, where vessels were within the port area, but where did they come from? Where did they go to once they left the port? And again, so here's a figure showing 24-hour track lines for vessels that passed through the Hamilton, Ontario port during 2019. And so this is a busy figure. I said there's a lot going on here. Some things might be surprising, some things might be hidden kind of underneath the different vessel tracks here. So I want to break this down a little bit further, but you can see that there are a variety of vessels that are moving in and out of the port. So that's the first thing. And you can see that there is traffic going up to the Seaway and going through the Welland Canal down into the Great Lakes. So those are just things to keep in mind. If we break this down a little bit further by zooming in, you can kind of start to see the traffic flows, right? You see there's that big purple swath along the northern end going to Oshawa and to Toronto. There's the bright yellow lines I'll point out are pleasure craft. So those are recreational vessels, usually, you know, private pleasure craft that are using AIS to transmit their location. And so you can kind of see that this might be, it's not necessarily a commercial marine transportation, but this could have an economic impact if you're looking at recreational industries and maybe infrastructures to support those kinds of activities. So that's another area of focus. If we look at just the vessels that self-identify as tug or towing, right? So they're probably moving barges, or maybe they're a single contained barge type vessel. If you're looking at for vessels that are moving, you know, in and out of Hamilton port, where are they going? And you can see a lot of them, probably the heaviest part is going along that northern part, northwestern part of Lake Ontario, with some traffic going down into the canal. And just to zoom in, so there's kind of different scales that you can use to investigate AIS data. If you want to look at regional level, if you want to look at port pairs or individual parts of the system, you can do that. So I zoomed in a little bit to make this figure, and you can see that there's really one main destination or port pair, and that is this part on the left. And that's going to one specific port, but there are some other vessel calls that are recorded going to, I think those are energy-related industrial areas further to the right. So this is just starting to reveal kind of traffic patterns, traffic trends in the area. And you could, of course, combine this with other land-based information sources to make a more complete picture of the supply chain that you're interested in, whether it's for energy commodities, timber commodities, agricultural commodities, kind of depending on how you look at it, you'll get a different answer. These track lines are for tanker vessels or vessels that are listed as not available, which is often tanker. And so you can see more discrete paths here, but again, going to Oshawa, to Toronto, and then some of the closer ports along that northwestern shore. Cargo, which is often, it could be bulk cargo, or these could be container ships. They often self-identify as cargo vessels. And you can see a very similar traffic patterns, but probably more traffic going through the canal, through the Welland Canal down into the rest of the Great Lakes system, as well as strong signals up into the St. Lawrence. So those are, pretty pictures. They give you some sense of where things are going to and coming from. What I did for this was just a really small analysis of looking at specific port areas. So not trying to get a sense of where vessels are when they're out on the open water, but if you're, connected in a supply chain sense to Hamilton, to the port, what other, how strong or how frequent are vessels calling between any two of these port pairs? So you can see there's a bunch of small gray polygons on this map, ranging from the entrance to the St. Lawrence Seaway in the upper right, all the way down to Cleveland, Ohio in the lower left. And you can draw these kinds of polygons for any area that you're interested in. We call them areas of interest, and look at traffic or travel time between different areas that you specify. And so what do those results look like? So this is a screenshot of a pivot table for those of you who are fans of Excel, and just getting a sense of quantifying this connectivity. So that's what the goal of this was. And you see the green column on the left are the departure AOI. So those little polygons, they all had a name. And I've highlighted the Hamilton row in yellow there. So if you're going from Hamilton to Clarkson, how many vessels were making that trip? And you can see there were 56 in this record in 2019. If you're going from Hamilton to Toronto, right, it's a bigger connection, there's 123 vessels. But if you're going from Hamilton to the Welland Canal, 379 vessels. So that gives you a sense of maybe a destination for some of the traffic coming out of Hamilton. And you can do this kind of analysis for a larger regional area or for specific vessel types if you're investigating a more discrete supply chain. So I just wanted to just share this with you as a sort of an initial, hopefully this is piquing some interest in using AIS data further. If we're looking at just a specific type of vessel, so looking at just tanker traffic that's shared between those same locations, you can see that if you're leaving Hamilton and going to the Welland Canal, that's the biggest sort of connection or destination, initial destination for tankers leaving Hamilton. Of course, it's not their final destination, but in terms of traffic patterns, it's something to consider. But if you're arriving in Hamilton, you're also probably coming from the Welland Canal previously, but that's not the only destination. So this is not going to probably be anything groundbreaking, but I wanted to show you what's possible and that using AIS data, you can get this quantified level of connectivity pretty quickly because you can identify different vessel types, even down to individual vessels if you're trying to look at specific resiliency aspects. So I think I'm almost at my time. So here's a quick summary. Just what can you do with AIS that's relevant to the supply chain and logistics investigations that you might be undertaking. So you can look at multiple scales, whether it's an individual port and the infrastructure within that, or looking at commodity-specific perspectives. So commodity is not a piece of an AIS message usually, but you can sometimes kind of reverse engineer just based on the vessel type and where they're calling, what commodities they're carrying. And especially for scenario exploration purposes. So if you're interested in studying resilience or logistics, you know, if part of a waterway is shut down for any reason, how might industries need to pivot and change their supply chain, or vice versa? If a railway or an important roadway is shut down, can water take the associated tonnage and handle it? And then down at the bottom there, I've listed some additional potential reading if you're interested in learning more about AIS or how it's being used in some of these different types of studies of resiliency, looking at structural interactions and so forth. And with that, I will thank you for your attention and turn it back over to the moderator. Thank you.
Well, thank you very much. Very interesting. I will hold questions until the end. If people have got questions, we'll hold those till the end of the three speakers and then come back to questions. So thank you very much.